Today's video is intended to help you work through homework 2.4 on the price setting firm. What we're told is that Apple sells iWidgets. It sells more iWidgets the lower the price it charges consumers, so it has a downward sloping demand curve. The demand for iWidgets is given by the equation willingness to pay equals 2000 minus 100Q, as shown in the table below. Meanwhile, it costs Apple $1,000 to develop the iWidget, that is to design it, and $100 to produce each iWidget. So its cost function is equal to 1,000 plus 100Q. This information will allow you to find the equilibrium price, quantity, and profit. So as we move through the problem, the first step at A is to copy and paste the table into a spreadsheet. So you can copy it. You'll need an empty spreadsheet. I'm going to use Google Sheets. If you like, you can use Excel. At this level, there's no real difference between Google Sheets and Excel for doing what we need to be able to do. Okay. The next question, B, asks you to verify the consumer's willingness to pay in the spreadsheet is identical to the equation listed above. The equation, we were told, is the willingness to pay equals 2000 minus 100Q. So I'm going to do that by simply adding an additional column, and I'll call it willingness to pay check. Right? The equation we're given, right, is that willingness to pay should be 2000 minus 100Q. The way you do that in a spreadsheet is you say, well, willingness to pay should equal 2000 minus 100 times Q. Instead of using the number Q, we had to say, okay, multiply it by that cell, right? And we get 1900. And we see we have exactly the same stuff. Exactly the same numbers. Here I'm going to just tell my spreadsheet that these are all dollars, and just to make things look a little bit more uniform. They also all those numbers could be right justified, and I'll use my regular Times New Roman font. Okay, so the first thing we've done is shown exactly what we needed to show. That the willingness to pay indeed, right, in our table, indeed matches the equation that I provided you. Next, it asks us to calculate Apple's cost of producing 1 to 15 units. And here, we need to return to the cost function. We're told the cost equals 1,000 plus 100Q. Right? That means we can say the cost equals 1,000 plus 100 times, and again here, we need to multiply by Q, right? Once you put in that equation, you can grab this little rectangle again and drag it down, right? What that's doing is it's telling the spreadsheet that, for example, producing 2 units is going to cost 1,000 plus 100 times A4, right? If you producing 1 unit is going to cost $1,100 because it's going to be the $1,000 plus 100 times 1, right? And the Google Sheet or the spreadsheet or Excel, understand that you simply always, when you drag that down, you simply always want to multiply 100 times whatever the quantity is. So it would cost $1,000 to design the iWidget and not produce any copies. It would cost $2,500 to design the iWidget and produce 15 copies, and so on. Next, on part D, you're asked to express Apple's average cost function as a function of Q. Well, the average cost as a function of Q would simply be equal to, the total cost divided by Q, or 1,000 divided by Q plus 100. You're also asked in your spreadsheet to calculate the average cost. Here, you could use that function I just said, but an even easier way to do it is to simply say that the average cost, since we already know the total cost here, we could simply take the cost, divide it by the quantity, right? Hit return, and the average cost of producing 1 unit, of course, is $1,100. But if you drag this down, you'll see that the average cost declines consistently as you spread out that fixed cost, $1,000 over more and more units, right? So if you produce 2 iWidgets, for example, if Apple produces 2 iWidgets, that would cost it $1,200, right? Since it'd be 2 of them, it'd have an average cost of $600. Or if you produce 15 iWidgets, the cost of producing them is $2,500. Divided by 15 is $167. Next, you're asked to calculate Apple's marginal cost as an equation, right? And then do it in the table as well. Well, the marginal cost is the first derivative of the total cost function, right? So if you take this function and take the derivative of cost with respect to Q, the 1,000 would drop out, the Q would drop out, and would just always be equal to 100. But we have an even simpler way to do it in the table. We can always say the marginal cost is always just what's the cost of producing one more unit. Well, the marginal cost, then you can think of always as the cost of producing any given number of units minus the cost of producing one fewer unit. And we see, it costs $100 on the margin to produce that first unit, right? If we drag this down, we'll see the marginal cost is always $100, which of course we already kind of knew from where the problem was worded, right? We said it costs Apple $1,000 to develop an iWidget and $100 to produce each iWidget. That means the marginal cost is always $100. Next, we're asked to calculate Apple's revenue. Calculate Apple's revenue when it produces 1 through 15 units. We'll ignore the second half of that question, although you can do an extra credit if you'd like, right? The revenue in all these examples is always simply price times quantity, right? However many units Apple sells multiplied by the price the price it sells multiplied by the quantity of units sold, right? So we can simply say the revenue is always going to be the price or the willingness to pay times the quantity, right? So if they sold 1 unit for $1,900, their revenue, of course, would be $1,900. If they sold 2 units for $1,800, their revenue would be $3,600, and so on. In part G, we're asked to calculate Apple's marginal revenue when it produces 1 through 15 units. And here we're going to do exactly what we did when we were calculating the marginal cost. Well, I should have copied this here. If Apple sells 0 units, they're going to have 0 revenue. The marginal revenue, right, is simply the change in revenue for Apple to sell to one more person. So the marginal revenue of selling to one person instead of 0 people, right, is going to be 1,900 minus 0. It's going to be $1,900. The marginal revenue of selling to the second person, right, even though we're going to charge him $1,800, we had to reduce the price for the first person to $1,800 too, which means the marginal revenue selling to the second person is going to be $1,700, right? Right, the $1,700 is $3,600 minus $1,900, and so on. Right? The important thing to recognize is that marginal revenue declines twice as quickly as the willingness to pay. So it actually gets negative by the time we get to the 11th customer, right? For Apple to lower its price from $1,000 to $900 to attract the 11th customer, that would actually reduce their total revenue by $1,000, right? Their revenue would fall from $10,000 to $9,900, right? No way they're going to choose to do that. All right, using what we know about Apple's marginal cost and marginal revenue, what quantity of iWidgets maximizes Apple's profits? Well, what we know is it makes sense for Apple to produce every iWidget and sell every iWidget where its marginal revenue still exceeds its marginal cost, right? If it can sell one more unit and selling that unit is going to increase its revenue by more than increase its costs, then it should obviously do so if it wants to maximize profits. And it just can continue to do this until we find the point where marginal revenue exactly equals marginal cost. So in this figure, I'm going to make this, just highlight this a little bit because this is the solution to a problem. Oh, where am I? Fill color, it's the solution. I'll make it this color, right? The 10th iWidget, the marginal revenue of selling that iWidget is $100, and the marginal cost is actually also $100, right? So actually, technically, they're just indifferent about whether or not to sell that 10th one, But in this homework and exam, it's easiest to assume, okay, let's continue to produce as long until marginal revenue exactly equals marginal cost. In part I, we're asked to verify that answer by calculating Apple's profit when it produces 1 through 15 units, right? And then we're asked how much profit does Apple earn producing the profit maximizing quantity, which we know now is 10 iWidgets. Well, profit is always simply equal to the firm's revenue. Sorry, start here. Equal to the firm's revenue minus its costs. Right? That's the definition of profit. So for example, if it designed the iWidget but sold no copies, it would earn a $1,000 loss. Right? But as it increases production, right, its profit of selling even just one unit for $1,900 would earn them $800 in profit, and so on. Here we see that profits continuing to go up as they sell. The lower the price, the seller to more and more customers until we get to 9 or 10 iWidgets. And here you see profits maximized at 9 or 10. We're going to assume here that 10 is in fact the correct answer. That's exactly where marginal revenue equals marginal cost. But if you gave me the answer that you think you should sell 9 widgets for $1,100, that would be fine with me as well. As saying that you're going to sell 10 iWidgets for $1,000 because you produce exactly the same profit, right? In any of these table examples, when marginal revenue exactly equals marginal cost for some quantity, it means, of course, that producing that unit is not going to increase the profit at all. But it's still okay to use that as the best answer. So how much profit does Apple earn? Apple is going to earn $8,000 in profit by selling 10 iWidgets for $1,000 each. Right. Using your answer in I, right, calculate the price Apple would have to sell its iWidgets for to make the same profit when it produces 1, 2 to 15 units. Use this equation to create values in the isoprofit column of your spreadsheet. So this is definitely the most challenging part of the homework assignment. I give it to you because I want you to understand that you can also draw isoprofit curves that look like the ones in the book. So we're actually using, in this example, we're using the marginal cost, marginal revenue rule to find the quantity of iWidgets Apple will sell, but it's still useful to be able to see that these isoprofit curves are not just totally made up. Right? What the isoprofit curve is telling us, it's saying what other combinations of price and quantity would produce the same profit. The same profit. Okay, I have a faculty meeting soon, so I need to finish this up. The same profit as we produce when we sell 10 iWidgets for $1,000 each. Right? So essentially, we want the profit to be exactly $8,000. Here, if you go to my key, right, you can see what equation I use. I'm even going to just copy that, right? Or remember it, right? What we need is $8,000 in profit plus the cost divided by quantity. That's the price we would have to sell at to get the same thing. So let's see if we can make sense of that, right? We would need the isoprofit curve to be 8,000 plus the cost. Oh, I forgot to put the equal sign in front. Plus the cost divided by the quantity. Oh, and that's going to be undefined, of course, for 0. But if I take that, I can drag it down. Right? There's no price that you could sell 0 widgets for and make $8,000 in profit. But what this is telling us is that we sold 1 widget for $9,100. That would produce us exactly $8,000 in profit, or 2 widgets for $4,600 would produce us exactly $8,000 in profit, and so on. Note that all these prices here are greater than what the consumer would be willing to pay for it. So they're not actually achievable until we get to this point right here, right? Where in fact you could sell 10 iWidgets to people for $1,000 and you're on the demand curve. If that part of the assignment is tricky, I would worry less about it. I just want your figure to look similar to what the figures look in the book. So in part K, then you're asked to create a figure showing Apple's willingness to pay average cost, marginal cost, and marginal revenue and isoprofit curves. Notice a few of the curves here are being omitted. They're not generally shown on the figures, right? The the total cost, right, we can't show on the figure. It's going to be much higher than the average cost and marginal cost and isn't necessary for working through the problem. Same with the total revenue and so on. So the way I'm going to do that is I'm going to give myself a little bit more space here on my sheet by making all the columns a little bit smaller. And then I'm going to highlight all the data and insert a chart. And this is one of the hardest things to do in a spreadsheet, to get things like this to work out well. So it frustrates me as well. We want it to be line, a line chart rather than a column chart. There's also a few of these variables I noted we don't want. So the willingness to pay is fine. We don't need the willingness to pay check. We found out they're exactly the same. The total cost, right, which is this yellow curve, that's not necessary. It doesn't help us. We can remove that, right? The marginal cost, we want. The revenue, we also don't want. I'm going to remove that. And the profit, we also don't want. I'm going to remove that. Everything else looks like we would like to have it, so that's good. There are a few other sort of changes we need to make. The x-axis right now, it actually quantity here shouldn't be on the vertical axis. That's actually something that should be on the horizontal axis. And this is one of the trickiest things, I think, for people when they highlight all the data, getting the right thing on the horizontal axis. But now this is how you do it in Google Sheets. So this is looking more and more how we'd like it to look. There are a few other changes that would be nice to make. I think most importantly, right, if we customize and we change the vertical axis, really we need to zoom in here a little bit. We don't care about the very high part of the ISO profit curve. So one way to change it is say we're only interested in minimum values of say minus 200 and maximum values of the height of the demand curve is 2000. Let's do 2200. Okay. And with a little bit more work, right, we can make the figure look exactly like the one in the key, including changing the color of the curves to better match the book and so on. But this is essentially, right, what we've created, right? The blue willingness to pay curve is the demand curve. This is the marginal revenue curve in green. Actually, that's the same color we've been using. The marginal cost is this yellow curve. Right, here's the average cost. The average cost is, of course, declining forever as you spread out the fixed cost across more and more units. And the profit maximizing quantity, where marginal revenue exactly equals marginal cost, is 10 units. And you can also see that that's exactly where the ISO profit curve is tangent to the demand curve. Is the profit maximizing price and quantity efficient? Explain. So the important thing to understand about the price setting firm is they choose a price that's above marginal cost. Sorry, that's the wrong figure. They choose a price that's above marginal cost. Right? They're charging $1,000, but it only costs them actually $100 to produce another unit. Right? So that's inefficient. It means the next consumer, the 11th consumer, is willing to pay $900, for example, for an iWidget, and it would only cost the firm $100 to produce that iWidget. The reason the firm doesn't sell to them is they can't tell who's who. They can't tell who's willing to pay each of these prices. So if they wanted to sell to the 11th consumer, they would have to reduce the price for everyone to $900. If they did that, their profits would actually go down a bit, right, by $200. Right? Their marginal revenue would be minus $100 to sell to that person, right? Which just doesn't make sense for them to do from a profit maximizing standpoint. So it's inefficient because there are a lot of consumers, 11 through 19, actually expanded this down, are all consumers who are willing to pay $100 or more, but they're not being sold to by this firm, right? I don't own an iPhone, right? Partly because I'm thrifty or whatever. I might like one if Apple was charging me something closer like the marginal cost of producing one, but their price isn't low enough that for me it's worth buying an iPhone instead of the cheap Samsung phone I have in my wallet, right? So this spreadsheet here is, not the most beautiful. I encourage you can see exactly the same thing by working through the key that I posted, right? You can click on all these things and see exactly what function I'm using. My figure looks a little bit better and so on. But I think that is, well, except for the extra credit, right? You can think about what quantity of iWidgets would maximize the economic surplus. I'll leave that to you to think about. So thank you for working through the first digital homework help.